question number 6, they're saying investigating the factors that affect the rate of reaction. Now we're talking of the rate of reaction with the factors. Some learners react calcium carbonate with excess dilute hydrochloric acid, and then in the conical flask the apparatus is set up as shown below. So they are saying they are reacting HCl, which is an excess lot of it. There will be too much amount of HCl with, they say they are reacting this with calcium carbonate, and then of course the production here, we're going to have once we have the carbonate, so it means we're going to have now this HCl is going to ionize to H plus Cl minus, and the carbonate we're going to have Ca2 plus CO3 2 minus. So they will just try to interchange. So the one with negatives will come to this one. So we're going to have Cl2Ca. So because chlorine, the calcium will need two chlorines, then they will come here, plus, now what do we have here? It must be the carbon dioxide produced, since we have this carbonate, so it means there will be CO2 carbon dioxide, then plus, what else can we have? Now the H and the oxygen there, they will form H2O. So this what will be produced, but we'll be tracking this one because this is not a closed setup, so it means this gas will be escaping there. Let's not do the balancing, but the key is that this, once we have the carbonate, it means we're going to produce the carbon dioxide, and then it's a gas, of course it will escape the system if we are not closing this flask. Right, they're saying the change in mass of the conical flask and its contents are recorded every minute. So there will be change in mass. Why there is change in mass? Because the gas will be escaping in this part. The results for this investigation are shown in the table below. Time when starting, we have a mass of 178. That is the start when before we start. When the time start reading, after 1 second, there is 1 comma. There is 176,2. After 2 minutes, 2 seconds, there is 174,1. So there is change in mass. So let's check the question. Write down the investigative question for this investigation. So when we're saying the investigative question, there must be a question mark. So what is factor here? We know that there will be, well, talking of the independent variable of the reaction rate. So the simplest one, we can say we measure the rate of reaction against time. So we can say, or we can talk of the mass. So we can say, how does the rate of friction change with time. Now this is our dependent variable. The rate of friction is our dependent variable, and means time will be our independent variable. But normally we agree that when you say this, we need to say need to have the independent and the dependent. And the dependent variable is always rate of friction, but the independent is one of the factor. And then the factor that affect the rate of friction, in this case, it's kind of not mentioned, but because when you say the mass is not one of the factor of the friction unless we say the surface area. So that's why we have time here. But of course, when you say the mass changes will affect the rate of friction. That's this one. They are saying state independent variable for this investigation. Of course, there will be time. So those who used as the mass, what is the relationship between the rate of friction and the change in mass, or the mass, then maybe the decrease in mass, then the independent variable here will be your mass, of course. The table is redrawn in the special answer sheet provided. So complete the table by filling in the values for the mass of, yes, the carbon dioxide that is being produced. So now let's erase here. Right, they're saying there is a mass of carbon dioxide produced. Now, what was the mass initially? Before the reaction start, the mass was 0. Now look at the change. The mass of carbon dioxide was 0, but the mass of the contents in the flask was 178. Then after 1 second, the mass was reduced to 176,2. Where did the other contents go? They went to the carbon dioxide. So we need to check how much carbon dioxide was escaped, so that we know how much was removed from 178. So we're going to say 178 minus 176,2. So we get 1,8. Now how much was removed after 2 seconds? So from 176,2, then there is 1. So we check how much was removed there. So we're going to say 176,2 minus 174,1. So in fact we must take it from the beginning. After 2 seconds, how much was removed? The total number of mass that was removed. So it's supposed to be 178 minus 174, 174,1. So saying you're using my calculator, saying 3.9. So we're going to check after 30 seconds from the initial, how much was removed from the initial, then we'll subtract here, then we get 5,3. Then we subtract this from the initial after the seconds. Then after 4 seconds, then we have 5.7. Then we subtract this from the initial of what we have. We have 5.8. We subtract another one here what we had. So after 6 seconds, we have 5.9. So the mass was not changing here throughout. So it means we had 5.9, 5.9, 5.9 throughout. Now this is what we have. That's how we got the mass of the carbon dioxide that is being produced from the initial amount of volume or the mass of 178 here. So every second when we remove from this total here mass. So that's what we have on the table. Now they're saying plot a graph of mass of carbon dioxide produced versus time elapsed. So there is a bar graph, or there is a graph shown there down that is given. That's this is what we need to have. So this side we must have the mass, and then of course versus time. So this side will be time in seconds. So this side will have this in grams. Right, we need to put the calibrations, so we can have 0 here, and then we can have spacing, so they are not that much. The time is up to 9. So let's see if we can have up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to end up here. And on the other side, we can also have 1. The mass 2, 3, 4, 5, 6. So the mass was up to 5.9. So let's plot at 0 and 0. There was no change. Then after 1 second, there was a change of 1,8. 1,8 is somewhere here of the production of carbon dioxide. After 2 seconds, there was 3,9. Yes, 3. Then you can have 0.5 here, 0.9 can be here. And then after that, after 3 seconds, there was 5.3. 5.3 can be somewhere here. After 4 seconds, there was 5.7, 5.5 here, 5.7 can be here. After 6 seconds, there was 5.9, very close to this one. Then after 7 seconds, we're having 5.9 again. 8, 5.9, 9, we have 5.9. Sorry for this, let's put it nice. So there is an error here. After 4 seconds, it is 5.7. Then after that, it's 5.9. 9, 5.9, 5.9, last one is 5.9 here. So this will be, let's start here, from 0, then this will be our graph. Right. And then the last thing, we need the heading, graph of mass of carbon dioxide versus time. Right, let's move up to check. Right, we plotted the graph. Give a reason why the mass of the flask and its contents remains constant at after 6 seconds. So what you can say here, when it remains, because remember on the reactants we had an excess, it means there is also a limiting reagent. So the HCl was in excess, so it means the other one, which is the calcium carbonate, was a limiting reagent. So that simply means one of the reactants is finished. It means the reaction is completed. So there will be no production of carbon dioxide. 6.6, they're saying calculate the total volume of CO2, carbon dioxide, produced at room temperature, 25 degrees Celsius. Assume the molar gas volume at this temperature is 24,46. Try to calculate the volume here. They're saying, okay, the molar volume, which is the molar volume, is given by this one. So, but for us to have that, the volume, what we have, if we had a, because what the formula saying N equals to V is the volume over the molar volume of a gas. But we don't have the volume of this gas. We have the mass. We have the mass produced, being the total mass is 5.9 grams. So it means we need to use that to get the number of moles will be mass over the molar mass. So what is the mass of carbon dioxide produced will be 5.9 over the molar mass of carbon dioxide. Carbon is the 32 plus oxygen 16. How many are they? They are 2 multiplied by 2. So what you get here, carbon, is it 32? The carbon dioxide, let's check. 32 or 60. So carbon is 12. Sorry for that. So carbon is 12. 1, 2 plus 32. That is 44. So it means we're going to have 0.13 moles. So that will be the case. So now that's where we come to this formula, because we have a molar volume and the number of moles. So we're going to substitute the volume now. So it means now we're going to say 0.13. Now we're going to multiply by the molar volume, which is multiplied by 24.46 equals to the volume. So when we multiply there, let's multiply, see what we get. 0.13 multiplied by 24.46. So we get a volume of 1 of 3.19 decimeter cube. So that will be the volume of the gas that is being produced. Right, now we're saying the experiment is now repeated at high temperature. Now we've increased the temperature. Remember, just an increase in temperature, the rate of reaction will increase. So the volume and the concentration of the HCl, hydrochloric acid, they said the volume and the concentration of the HCl and the mass of calcium carbonate used are the same as in the original investigation. So it means we're going to produce the same amount of carbon dioxide, but will be produced at higher rate. So because of we're keeping everything the same, but changing the temperature to higher, the rate will be faster, meaning that only the reaction that will be faster, but the products will remain the same. The amount of the product will remain the same. On the same set of axes used to draw the graph in question 6.4, draw a sketch graph, just to sketch graph of mass of carbon dioxide produced versus time elapsed at higher temperature. Label the graph N. Now let's do that quickly to have the graph. So let's check we've drawn our graph. So now we're going to have higher rate, meaning the graph must be approaching the y-axis here. So meaning we're going to have our new rate like this. Now they must be at the same. Now you can see the graph is turning. This will be N. The graph is starting to be flat after 3 seconds, but this one is starting to be flat after 6 seconds. Can you see now this reaction will finish faster than this other one? Let's say that's a rough sketch of that. So fine, let's go back to the last part of question 6. Use collision theory to explain difference between two graphs obtained. Now we must use the collision theory here. One, we said we must put this in bullet form when we're doing the collision theory. So one, we can say the molecules, when temperature is high, we can say temperature increased. Temperature increased, but our points start here. Molecules will gained greater or high kinetic energy. So we must show us that there is a greater or high kinetic energy as the temperature increased. Now it means there will be more effective collisions per unit time. Simply saying more particles will collide more often. The last one, of course, the reaction rate. Is higher. Therefore, the reaction is higher or has increased. As that will be question number 6. That was a long question.